All right, for the last part of 5-6, we're going to find the area of a triangle. Keep in mind that we already know how to find the area of some triangles, okay, particularly right triangles. Okay, as we discussed yesterday, if we have a right triangle, okay, we know that if the right triangle has a base and a height, that the area is equal to 1/2 times the base times the height. So a convenient formula when we have a right triangle. Okay. We also have been able in the past to solve using that same formula triangles like this if we were to have the base and then an altitude running from the base perpendicular, okay, up to the other vertex. Okay, if we had those two quantities, if we knew those, we could find the area with the same exact formula. Okay, we discussed in geometry. Okay, well, even though this is not a right triangle, it's still the same formula. Okay, but one of the issues that we have though in real life is that sometimes triangles we're not going to be given that information to be able to figure out that height. Now, knowing what we know about the law of sines and cosines, etc., okay, if we had this base and maybe we had an angle or two, okay, we might be able to determine that height, and if we could, then we could use our normal formula. Okay. Now, there's a couple other formulas that we did not learn about in geometry, and that's these three formulas, which kind of like the law of cosines, is really the same formula, just with the different sides plugged into it. Okay. What we want to do is take 1/2 times the two sides we're given times the angle in between. So notice, like I said a minute ago when we did our law of sines, if I have side A and side B and angle C, okay, this is always going to be a side angle side case. Okay. So anytime we have a side angle side case, okay, then we can use one of these versions of this formula. Fair enough? Okay. So unless it's side angle side though, okay, then we won't have enough information to use this. Okay. Now if we have some other case, could we use the law of sines or cosines to figure out enough information to be able to use this? Sure, because ultimately if you found a missing side or a missing angle, then you might have yourself a side angle side case, and then you could use the formula for the area. Okay. But if you have a side angle side case right off the bat, then it's a piece of cake. Just plug in the numbers and do the math. Fair enough? Okay. Now, we do have one other formula that we're going to look at. Okay, and in this case we're given sides A, B, and C. So this is the side, side, side case. Okay. So if we're given a side, side, side case, okay, we can find the area of a triangle by using what we call Heron's formula. Okay. And what Heron's formula involves are the three side lengths, okay, along with this value of S. Okay, and this S is what we call the semi-perimeter. Okay. So to be able to use the formula, you first have to calculate the semi-perimeter. So you need to take the three side lengths, okay, add them together, divide by 2, okay, that gives you the semi-perimeter. Now this seems like kind of a weird formula, and we're not going to take the time to go through the derivation of it and why it works. Okay, we're just going to do the using part. We'll trust mathematicians that this actually works. Okay, so ultimately, again, we're going to calculate the semi-perimeter, okay, and then we're going to use the area formula to determine the area. Okay. So let's go ahead and do that with this example. We have side lengths here of 10, 12, and 14. As I mentioned yesterday, one thing you want to be careful with here too is that make sure that you actually have sides that give you a triangle. Okay? Because like I said, if this was 10, 12, and 24, then we would say there is no area because it's not even a triangle. Okay? So remember your triangle inequality. Your two smaller sides have to add up to be greater than the third side, which in this case they certainly do, so we do have a triangle here. Okay. So what we're going to calculate then first is S, which is going to be 10 plus 12 plus 14 divided by 2. So in our case, our S value is going to be 2236 divided by 2 is going to be 18. Okay. So 18 will be our S value, our semi-perimeter. Okay. And then from there, the formula is the square root of S times S minus A times S minus B times S minus C. And if we fill in the blanks, 18, S minus A for us would be 8, S minus B for us would be 6, and S minus C for us would be 4. So we get 18 times 8 times 6 times 4. And depending on the context of the question asked, okay, we get 3,456 as our square root. If they ask you to give the decimal version of that, they tell you to round it, okay, then of course it's a calculator problem. Okay. If you are instructed not to round it, give an exact answer, then we're going to need to give this in the simplest form. So just let's go ahead and review. You can try to find perfect square factors of that, or you can use that box technique that I showed you to figure out if that breaks down at all. So if I do divide it by 2, it's even, so that's certainly divisible by 2. I get 1728, divide that by 2, get 864, divide that by 2, I get 432. Keep breaking this down until we find a prime. Divide that by 2, divide that by 2, divide that by 2. Finally, we can't divide by 2 anymore, so we get to divide by 3 now. We get 9, 3 and 3. So we got quite a few factors here. And remember what we want to do to determine what comes out is to circle any pairs that we have. Okay, anything that can get paired up comes out. So we got 2, 2, and 2. That makes 8 altogether. Remember, this is a multiplication process, not addition. We don't have 6 coming out. We have 8 coming out. 2 times 2 times 2. But we also have a 3 coming out. So not only do we have 8, but we also have a 3. So 8 times 3 would be 24 out. And then what's left in is the uncircled items, which are the 2 and the 3. So final answer then, exact value-wise, would be 24 radical 6. Okay. Okay, questions so far? Okay, so for our work today, in the second half of our 5-6, we're going to be working on some problems involving finding areas. Okay, so using this formula and the previous formula. Okay.